Today we're going to look at the properties of logarithms. The first property shows us multiplying two numbers together, and now we can expand them. And we've seen this also with exponents, where if you multiply, you add. So the property holds true. For example, if we had this, we would say 2 plus 5 is 7. So it's the same, really the same property. And if you look at the order of operations, please excuse my dear Aunt Sally, you're going to notice that logs and exponents go from left to right also. And logs and exponents are at the same level. Anyway, here, if you divide two numbers, you can expand and make that two separate logs with subtraction. Property 3 is my favorite. It helps us simplify a lot of problems. And all it says is that you can take the exponent and bring it right around front. And eventually we'll see why this works. Okay, so exponents and multiplication very closely related. Let's look at some identities for logarithms. Log base b of 1 equals 0. And this makes sense. If we were to convert it, we know anything to the 0 power is 1. So that makes perfect sense. If we look at this and convert this, b to the first power is b. So that's pretty obvious there. And this one, if we bring this around front, then we know this part is 1. So we just have x times 1 is x. Now this one, if you were to convert this to exponential form, it's in exponential form, but if we converted it to log form, we would have the exponent equals log of the same base of x. And you would see it's a perfect equality. So this one comes from just converting. And here we know that the natural log is really log base e. So this is log base e of e equals 1. And that's the same as property b. Alrighty, let's actually apply some of these properties. It says expand. So we're dividing, so we're going to use the second property and expand. So this is log base 7. You always have to watch the base. X minus log base 7 of 3. And it's just that easy. We've expanded, and now we have a simple term over here and over here. Alrighty, let's look at example 2. We're going to need to use the first two properties on this. And you have to be very careful here. So, first, I'm going to say log base 6 of u minus log base 6 of VW, Volkswagen. And now I'm going to expand the second part, but I need parentheses, log base 6V plus log base 6W. And now we distribute the negative sign, and we get log base 6U minus log base 6V minus log base 6W. And I always have students that mess this sign up right here. One way you can always remember it is everything in the numerator is positive and everything in the denominator is going to end up negative. So notice that the U part is positive, the V part is negative, and the W part is negative. Okay. Now we're going to expand, and the first thing I want you to understand We're using the third property, but I want you to remember that the cube root is really the 1/3 power. And now I'm going to bring that exponent around front. That's the third power. That's the third property. Okay, so when we expand, we always move the exponents around front. Example 4. We're going to, again, combine properties. We're going to use the first and third property. So we're going to expand using the first property. And now we're going to bring the exponents around front. And as you get good at this, you won't even need 2 steps. You'll be able to do it in one swift motion. But when you expand, you must bring exponents around front. Okay. Alrighty, now number 5. Whew. Go ahead and pause your cameras and give that one a try on your own. There's a couple of ways you can do this problem. The first thing we want to do is understand that that's all to the 1/4 power. All of the variables anyway, not the log. Okay, so you have a choice here. You can distribute here first, or you could bring the 1/4 around front and distribute later. It's definitely up to you. I personally like to distribute at the end of the problem. So I bring the 1/4 around, and then I like to expand this way. Minus, because it's in the denominator. Remember, everything in the denominator is going to end up negative. Now I'm going to bring my exponents around front, if there are any. And like I said, you'll get good at this where you won't need so many steps. But right now, I just want to make sure you see where everything is coming from. So now I'm going to distribute the 1/4 to all coefficients. So 2/4 is really 1/2. One-fourth. And 3/4. And if we had distributed the 1/4 in the beginning, you would have gotten the same answers. Okay, let's look at example 6. We're going to write as a single log. So now we're going backwards, okay? We're going backwards. We're going to mush all of this together. So the first thing I'm going to do is put my exponents back up top. So I get log base 2 of y cubed plus log base 2 of z to the 5th. Now this only works because we have the same base. If the bases were not the same, we would not be able to combine them. Maybe unless you did a base change formula, but then that gets tricky and real fun. So now what I'm going to do is I notice this is addition. So I'm going to use the first property. And I'm going to multiply these together because it's addition. Alrighty, example 7. I'm going to write as a single log. So when you have fractions, that's telling me that this is going to end up with a radical. So what I want to do is I want to have a common denominator so that they all end up under the same radical. So the first thing I'm going to do is decide on a common denominator. And I think I'm going to make my denominator 12. Because that'll work for all of them. So I need to do 3 over 3. I need, 6 over 6. And no, I don't want to reduce. I'm getting the common denominator for a reason. Okay, now that I have my common denominator, I'm going to actually factor that denominator out. Isn't this fun? So notice we're just going backwards from the last problem. Okay, and now I'm going to work on the inside. And I'm going to put everything together. And I'm putting my exponents up top. So I'm going to show you how to do that without an extra step. So in the numerator, remember everything positive goes in the numerator and everything negative goes in the denominator. This is positive, so it's in the numerator. Promise. Okay, so now the 1/12 is going to come back around here, but it's really going to turn out to be the 12th root. So you can do 2 separate steps if you want. But I just want to make sure everyone understands. And the log is not under the radical. The log is not under the radical. So I have x cubed, z to the 4th, and y to the 6th. Ooh, that was fun. Okay. Example 8. Write as a single log. Now I'm starting to prepare you for solving equations with logs. I'm getting you ready for our next lesson. But there's no equal sign yet, but we're getting ready. Remember subtraction. Positive goes in the numerator. The negative stuff goes in the denominator. Now, we need to see if this is going to reduce or not. So I'm going to factor the numerator just to double check and see. So let's see, what do I need? 1 and 4, negative on the 1. So indeed it does factor. So in the numerator, I'm looking at x minus 1, x plus 4, putting those first semester skills in action. And now, ooh, that cancels out. So now we just have log base 10 of x minus 1. All right, that was fun. And this, by the way, this is different from log of x minus 1. Do you see the difference? Because in order of operations, logs come before subtraction. So we have to put the parentheses to make sure that's locked together. Okay? So I just want to make sure that you understand that that's different. Okay. Example last, but we got 3 parts here. We're going evaluate. Notice there's no variables here. So let's see if we can use the properties to simplify and then actually evaluate. So what I'm going to do here is I'm going to bring 4 to the front. I always like to bring my exponents to the front whenever possible. So now I'm saying 2 to what power equals 32? I believe that's 2 to the 5th power. So now I'm going to take that out, and 4 times 5 is 20. That's much better than trying to get a calculator and figure out what 32 to the 4th power is. No, thank you. So now, if we look here, I don't know what log base 2 of 40 is, but I see subtraction with the same base. So what I'm going to do right here is I'm going to use the property that says I can divide 40 divided by 5, and that's log base 2 of 8, and 2 to what power is 8? It's 3. Alrighty, our last example. So, wow, we have 3 parts here, and we have log base 4. Everything positive is in the numerator. So that's 8, that's 16, and 2 goes in the denominator. So let's see. I already see I can go 2 goes into 16 8 times. So that's log base 4. And I have 8 times 8 is 64. So now I'm asking 4 to what power equals 64? And that would be the 3rd power.